Okay, today we're going to add and subtract rational expressions. So again, what is a rational expression? A rational expression is a fraction. Anything that can be written as a fraction is a rational number. So a rational expression is just any expression that can be written as a fraction. Today we're focusing on adding or subtracting. So just think about how we add or subtract any numbers in general. To add or subtract any sort of fractions, we must have a common denominator. So to add or subtract, let's fix that S. That doesn't look very good, does it? So to add or subtract rationals, to add or subtract fractions, why don't we just say fractions? You must have the same denominator, common denominator. So step one is going to be, in order to add or subtract rational expressions, is going to be to factor, if possible. So let's put this into practice by looking at an example. So how are we going to add, let's say we have the rational expression 5x divided by x squared minus 9 plus 2 divided by minus 3. Okay, well, technically here we have two fractions. In order to add fractions, I have to have the same denominator. So let's look at my denominators. I have a denominator of x squared minus 9, and I have a denominator of x minus 3. Those are not the same. So first step is, let's see if we can break down this second fraction, or this first denominator. Well, x squared minus 9, that is ding, ding, ding. 9 is a special kind of number. That is a difference of squares. So let's factor out this first denominator, parenthesis, parenthesis. So square root of 9 is 3. And since it's a difference of squares, one's positive, one's negative, that's how I don't have a middle term. So first step is to factor. If something is not linear, factor it down. So let's see. Our first denominator has x plus 3 and x minus 3. Our second denominator only has x minus 3. So we need to multiply by what is missing. Okay, in order to get the same, you need to multiply by what is missing. So our common denominator here, so we're going to find a common denominator. And for this problem, okay, our common denominator is going to be what they both have, which would be x plus 3 and an x minus 3. So we need to turn these into having both of them. So we need to multiply by what's missing. Well, this first denominator already has both. We don't need to multiply by anything, right? It has an x plus 3 and it has an x minus 3. We are good. Now the second one only has an x minus 3, right? So here, what's missing is the x plus 3. So I can do whatever I want, but then multiply the bottom by x plus 3 as long as I multiply the top times x plus 3. So what we need to do here is we need to multiply by what is missing. Multiply top and bottom by what is missing. So we're going to multiply top and bottom. By what is missing. Oops. Okay, because again, I'm really just multiplying by 1. X plus 3 divided by x plus 3, anything divided by itself, that's just going to cancel equal 1. It's a fancy one, but it will equal 1. So let's go ahead and multiply by what's missing. We're not going to quite FOIL out just yet. So we end up here with a 5x over x plus 3, x minus 3. I'm going to go ahead and distribute out the numerator. We're not going to distribute out the denominator. Now that I have a common denominator, I can add the numerators. Because how do we add fractions or subtract fractions? You add or subtract the top and you keep the denominator the same. So because we can add numerators here. Add the numerator. So add the numerator, denominator stays the same. Stays the same. So again, our denominator is going to stay the same at x plus 3, x minus 3. But we can add our numerators. So we have 5x plus 2x plus 6. Well, that's nice because we have some like terms. 5x plus 2x is 7x plus 6 over our common denominator, x plus 3 times x minus 3. And we look at our numerator. Can we factor out anything? 7 and 6. No, 7's already prime. So we're not going to be able to distribute anything there. What we could do is we could FOIL the denominator if we wanted to. Since I can't distribute anything. Or you can draw a 2 by 2 box. So we end up with 7x plus 6 on the top and x squared. Your outer and your inner are going to cancel because it's going to be a difference of squares. You're going to end up with x squared minus 9. Now, just like with multiplying and dividing rationals, our denominator can never, ever, ever be 0. So let's look at our common denominator. What was our common denominator here? Our common denominator was x plus 3 times x minus 3. Well, if x plus 3 cannot equal 0, that means that x cannot equal a negative 3. And if x minus 3 cannot equal 0, that means that x cannot equal positive 3. So we have to add on those restrictions to the domain. So this would be your final answer along with restrictions to the domain. Again, why are these as such? This is because x plus 3 cannot equal 0. This is because x minus 3 cannot equal 0. Okay, denominator cannot equal 0. So let's try another one. So let's look at this example. We have x divided by x minus 1 plus 2x minus 1 divided by x squared minus 3x plus 2. So first step is if we're going to add fractions, we need to have a common denominator. So let's look at our two denominators. Are they the same? No. So first step is we need to factor, okay? Because we have this quadratic here, we don't need to do anything yet with the first fraction. But let's ask ourselves, can we find two numbers that multiply to 2, but add to negative 3? Well, if we think about that, the only way to get 2 is 1 and 2. If we need a -3, that's going to be a -2 and a -1. So again, this is just factoring. So now we need to multiply by what's missing. So what do we notice? I have an x minus 1 in this first denominator. I have an x minus 2 and an x minus 1 in the second denominator. So what's missing from the first one? The first one is missing the x minus 2. So let's go on ahead and multiply the top and the bottom by what's missing, which is the x minus 2. So again, you have to do the top and the bottom. So we're going to multiply this times x minus 2 and this times x minus 2. So again, what are we doing here? We're going to multiply by what's missing. Multiply the missing part. Okay, so we're going to distribute, I'm going to distribute the first denominator. So x times x is x squared. X times -2 is -2x. And just keep the denominator the same. And now that we have the same denominators, I can simply add the numerators. So denominator stays the same. I still have x minus 1 times x minus 2. But I can now add the numerators. So I have x squared minus 2x plus 2x minus 1. So let's distribute. What do we notice about our two middle terms? -2x plus 2x. Those are going to cancel. So we're left with x squared minus 1 on top, x minus 1, x minus 2 on bottom. But we're not done, because let's look at that numerator. Ding, ding, ding. X squared minus 1. 1 is a special kind of number. That is a perfect square. That is a difference of squares. So that means that I can factor my numerator as parenthesis, parenthesis. Square root of 1 is just 1, and with it being a difference of squared, that means we have a positive 1 and a negative 1. Again, still over our common denominator, x minus 1, x minus 2. So let's see, can we simplify anything? Does anything cancel? Does something divide by itself? And yes, it indeed does. I have x minus 1 on top, x minus 1 on bottom. Those two cancel. We are left with x plus 1 on top, x minus 2 on bottom. But we are not done. You cannot forget to add your restrictions. Your denominator can never, ever, ever equal 0. So let's check all the denominators. Anywhere we have a denominator, and we have to exclude those x values. So what was our common denominator? X minus 2 cannot equal 0, therefore x cannot equal 2. Again, if you need it written out why, this is because x minus 2 cannot equal 0. And lastly, we have x minus 1 cannot equal 0, so x cannot equal positive 1. So again, this is because x minus 1 cannot equal 0. And both of those are because your denominators cannot equal 0. Denominators cannot equal 0. So your full complete answer to these two rational expressions added simplifies to x plus 1 divided by x minus 2, with the inclusion that x cannot equal 2 or positive 1. So again, these are multi-step. Okay, these are not difficult. It is definitely multi-step. Have to get a common denominator, have to factor out, see if anything simplifies, and you have to add your restrictions on the domain at the end. So let's try one more. Okay, let's take it up a notch, and now let's subtract rational expressions. So let's look at the example. What if we have x minus 1 divided by x plus 5 minus x plus 3 divided by x squared plus 6x plus 5? Okay, just like with adding fractions, our goal is to get a common denominator. So if we look at our two denominators, currently they are not the same. I have an x plus 5 on the left, and I have a quadratic on the right. So let's break down that quadratic on the right. Let's try to factor, get it into smaller linear components so that we can see what is missing from the left-hand side. So when we're factoring, again, our whole goal is to break down into linear components. So we are looking for two numbers that multiply to 5 but add to 6. Well, 5 is prime. There's only one option to get 5, 1 and 5. If we need a positive 6, that means that we need a positive 1 and a positive 5. And our numerator stays the same. So now we have the expression x minus 1 divided by x plus 5 minus x plus 3 divided by x plus 1 times x plus 5. So that is simply factoring. So now we need to get a common denominator. So let's look and see what is missing from our first expression. Well, we have an x minus 5. What is missing is the x plus 5. So again, we have a lovely rule in algebra. I can do whatever I want to the bottom as long as I also do that to the top. So we're going to multiply the first fraction, top and bottom, by x plus 1. So here we're just getting common denominator. Get common denominator. So let's FOIL the top. Okay, if you FOIL the top, again, you can draw a box. If we FOIL the top, we're going to get x times x is x squared. X times 1 is 1x, right? Negative 1 times x is negative x. Negative 1 and 1 is negative 1. And again, we're not going to quite FOIL the bottom yet. Just keep it the same. We again are subtracting this by x plus 3, again over x plus 1, x plus 5. So what do we notice about our middle terms? Our middle terms are actually going to cancel, if we notice. And we're left with x squared minus 1 on top over x plus 5, x plus 1. Again, minus x plus 3, again over our common denominator, x plus 1 and x plus 5. Okay, now that I have common denominators, I can subtract my numerators. So I have x squared minus 1. Here's the tricky part, minus parenthesis x plus 3. All over the common denominator of x plus 5 times x plus 1. So, cannot stress this enough. Make sure to put minus and then a parenthesis. Now, with addition, you're distributing it a positive, so it's not really changing your signs. With subtraction, it makes a huge difference. So, if I subtract that negative, I get x squared minus 1. This would be minus x. This would be minus 3. Divided by x plus 5 times x plus 1. So if we combine like terms, I have here a negative 1 and a negative 3. So we have x squared minus x. Negative 1 minus 3 is negative 4 over x plus 5. Let me make that bigger. X plus 5 times x plus 1. So let's see, are we going to be able to factor? Let's look at my numerator. I have a quadratic, so can we find two numbers that multiply to -4, but that adds to -1? Well, options for 4 are 1 and 4. Well, 1 and 4 is not going to get me -1, or 2 and 2. That's not going to get me -1, which means we can't factor it. That's as small as we can get it. So you might have your answer written as this. You might also see it where this is foiled out. You can do it either way. We'll just go ahead and leave it like this. But you cannot forget with rationals, you have to put restrictions on the domain. What can't x equal? So let's look at that denominator. X plus 1 cannot equal 0, therefore x cannot equal -1. X plus 5 cannot equal 0, therefore x cannot equal -5. And again, where are we getting this from? This is because x plus 1 cannot equal 0. This is because x plus 5 cannot equal 0. And both of these are because the denominators cannot equal 0. So final simplified answer, x squared minus x minus 4. All of that divided by x plus 5 times x plus 1. But we have the restrictions, some vertical asymptotes. X cannot equal -1 or -5.